I'm Philipp. I'm final year PhD student at TU Berlin, and I will also talk about query compilation and interpretation, and basically our journey, how we use this technology in Nebula Stream, our stream processing engine which we built. And actually, over the last 3 years, we built actually 3 query compilers, different prototypes, and we actually started a Nebula Stream initially with the idea that we want to use query compilation in our system. Then we built a prototype Grulich to explore basically how we can leverage adaptive optimizations for query compilation and how we can change the generated code at runtime towards data characteristics. And then we introduced query compilation to accelerate UDF-based workloads in high-level languages like Python or Java, and how we can combine this with relational operators. And overall, we are really happy with this approach. Query compilation gave us great performance. It allows us to specialize code towards data and hardware characteristics. So this was really great. However, it also introduced a high system complexity and required a high engineering effort. And as a result, from the PhD students working on the system, only a small portion was actually able to introduce new features and to implement new operators. And this was like a big problem for us because basically our velocity of introducing new features decreases. And we were not the only one having this problem. Also, other researchers basically said, okay, it's great for performance, but in the end, it's really difficult for students to maintain and to debug code. And the reason is that you basically generate code at runtime, which is compiled, and that's quite complex to implement operators. There are some solutions to address these problems. Basically, you can have better tooling, you can have better abstractions, but in the end, you always introduce more engineering effort, which somebody has to maintain, and this is quite a problem. And as a result, we see actually in industry that more and more systems choose to actually not use query compilation, but basically use interpretation-based engines using vectorization. And just because interpretation engines seem to be simpler to maintain and to build. So we were quite depressed and thought about, okay, let's take a step back and think about what we actually want. Can we somehow build an engine which unifies basically and gives us the benefits of interpretation-based query execution, but still gives us the flexibility and maybe in some cases performance advantages of query compilation. So let's think about what goals we have when we build an engine, a new query execution engine for Nebula Stream. We want to have a push-based, interpretation-based engine. So our operators push data from the data sources towards the data sinks. And from a user perspective, it basically looks like an interpretation-based engine. This fits really well to a model-driven prioritization scheme, which was shown to be efficient on modern hardware. We want to have our operators implemented in standard C++ code. Students can understand the code, they can use basically normal control constructs like loops, they can use abstractions, which they are used to, and they can use standard debugging tools from the IDEs without that we have to maintain and engineer new tools just to enable debugging. And then we want to have an automatic approach, which somehow can translate our native operators to an intermediate representation, which we can compile down to efficient code using different compilation backends. So we want to support LLVM to get high performance, or we want to use, for instance, Flounder from TU Dortmund to get very small query startup latency. And we introduced that in Nebula Stream, and we now have a framework which basically gives us high developer experience, but still gives us the benefits of query compilation. So if you have any questions, drop them now or we can chat a little. Thanks.